Oh, hi! I'm tinkering with these peculiar little flashlights that use light-emitting diodes. You probably know them as LEDs. Now this one is pretty conventional. Close the switch and it lights up, and you can see the color is white. This one's blue and red. I think I got ripped off on this one. This one's supposed to be green, but I'd say it looks more like yellow. Now this guy's different. You turn it on and you don't see anything. But trust me, there's light there. It's light that's invisible. Now I would say that its color is near infrared. Now our eyes don't see infrared. I can't see it, you can't see it. But some things can, like this little photocell. It's a kind of solar battery. It can see infrared, and when it does, it lets us know about it by outputting some electricity. Now I've connected it to a meter here, and watch what happens when I hit this flashlight. Ha! See the needle move? It's seeing infrared. When I press the button on this remote control, it sends out flashes of infrared light. Of course, we can't see it, but our photocell can. Now replace the meter here with a little sound system. Listen. The sounds change because each button has a slightly different flash pattern. Now a home video camera can also see infrared, and since you're seeing me on a video camera, watch what happens. Most home video cameras can be modified so that they see absolutely no visible light at all, just infrared, or at least that part of the infrared that we call the near IR, the near infrared. Now in the near infrared, many objects look quite different. Here is a big Montana sky, but viewed in the near infrared, that sky is black. In the infrared, the leaves of trees turn milky white. Notice the conifers, the spruce and the fir trees just to the left. They appear much darker. Snow? No, just healthy grass. In infrared, the appearance of unhealthy plants is much different. That makes infrared a useful tool for detecting diseases in forests, crops, and grasslands. Here we have a couple of signs. Now cover them with a piece of fabric and they become practically unreadable because this fabric blocks most of the visible light. Now watch that same event in the near infrared. That's the image on the bottom. The top half is the visible light. Well, I guess it's a good thing our eyes can't see infrared, because there'd be a lot of clothes we shouldn't be wearing. Now I want to go from the near infrared into that region where the wavelengths are roughly 10 times longer, the mid-infrared. Now to see mid-infrared, we're going to need a different kind of camera. A thermal imaging camera, like the ones firefighters and rescue workers use when they need to see through the smoke in a burning building. Now everything gives off radiation. Physicists call it blackbody radiation, and it's closely linked to temperature. Now the temperatures we experience range from maybe the coldest winter night to the inside of a kitchen oven. And for this range of temperatures, the associated blackbody radiation is in the mid-infrared. Exactly what our thermal imaging camera sees. So this camera can be used to distinguish temperatures. In general, an object that is hot will appear very light, even white, while that same object cold may be black. This link with temperature can be seen in these two hot plates. In the infrared, both burners are black because they're cold. Now heat up the rear burner by flipping the switch. See it turn white? Here Greg rubs his hands to warm them up a bit. See the result in the infrared? Now Greg puts a couple of hot spots on his shirt.
Here we see Janelle's feet and her shoes. Now remove your right shoe and remove the left. Good girl. Now don't remove anything else. Just walk away. Ooh, does this chick have hot feet? Now watch the infrared image as Jeff draws on his face with a piece of ice. Notice that he also dribbled a little ice water on his shirt.
Now his hand is wet with ice water. What does he do? He wipes it on his shirt.
After Greg leaves his chair, there's no evidence that anybody was ever sitting there. At least not in the visible light. But in the infrared, Greg leaves behind a heat pattern. We saw Janelle had hot feet. Now we see what parts of Greg were warm. Look for the image of the belt and the belt loops on the back of the chair. This is Greg's hand, but with that plastic bag over it, we can't tell what that hand is doing. For all we know, Greg could be giving us the finger. But with the infrared camera, we can see right through that bag. He's giving us two fingers.
Viewed in the mid-infrared,
the liquid coming from the faucet looks black, like crude oil. But in the visible light, we can see that it's nothing but ordinary tap water. Cold tap water looks black in the infrared. Now the guy on the right, that's the one in the 3rd trimester of pregnancy, is going to switch the water from cold to hot. The water changes to milky white, because that's what hot water looks like in the infrared. I guess Greg thinks with this bag on his head, nobody will recognize him now, unless they've got an infrared camera.
So, that's the end of a little field trip into a world of infrared. Fascinating stuff. As Paul Hewitt would say, physics. Yum yum. Can we say that without a legal clearance?